Hey everyone, how's it going? In this video, we're going to discuss what acceleration is. So, to do that, let's think about what velocity is. Velocity is my change in position, so change in position over my change in time. So basically my velocity is how quickly my position is changing divided by how quickly time changed. Acceleration we can think of as being pretty similar actually, except acceleration is my change in velocity divided by my change in time now. Change in time. So you can think of velocity as being the derivative of my position and acceleration as being the derivative of velocity. So another way to think about it would just be if I say x is my position, I can think of it as being dx dt. And if v represents my velocity, I can think of acceleration as being dv dt. Okay? So basically the equation for acceleration, again, we're going to write it as the average acceleration. We can say is my delta v, so my change in velocity divided by my change in time. Now, the units for this, if we think about it, the units for velocity are meters per second divided by seconds, which comes out to be meters per second times second, which is just meters per second squared. So this is the units you will see associated with acceleration. Now, let's do an example. So I have a car right over here, and let's say it's traveling this way at 5 meters per second. And then let's say 4 seconds go by, and now we're traveling at 45 meters per second. So what is my average acceleration? So let's just plug it into the formula. So my average acceleration is equal to my change in velocity over change in time. My change in velocity is just my v final minus my v initial over my time final minus my time initial. Now, what's my final velocity? Well, that's 45 meters per second minus my initial velocity, which is 5 meters per second. So 5 meters per second there. Divided by, what's my change in time? Well, assuming we started at this position at time equals 0, right here we're at time equals 4 since 4 seconds have passed. So I can say my time final is 4 seconds minus 0 seconds. What does this give us? This gives us 40 over 4, so 40 meters per second over 4 seconds, or 10 meters per second squared. Okay, so that one's not too bad. But that was an example where we're speeding up. What about an example where we're slowing down? So let's say we have that same car, and it's traveling 20 meters per second. And then 6 seconds go by, and then we've slowed down to just 8 meters per second. I want to know what my acceleration is. So again, we're going to plug in. Acceleration is equal to my change in velocity over change in time, v final minus v initial over t final minus t initial. My v final is 8 minus 20 meters per second over 6 minus 0 meters per, not meters per second, just seconds. So what does this come out to? Negative 12 over 6 or negative 2 meters per second squared. So what are we seeing here? We're seeing here that when we have a positive acceleration, our velocity is increasing, and when we have a negative acceleration, our velocity is decreasing. So all this talk that we have about acceleration and deceleration in real life, You don't have to think about it as being deceleration, actually. All you have to think about is being negative acceleration. Okay? So, just to round up this topic, if I have a car that's, say, moving in this direction, and I wanted to draw my accelerations depending on whether they're speeding up or slowing down. Well, you can think about it as being acceleration causes me to speed up when it's pointing in the same direction as my velocity. So if this is my velocity, this will be my acceleration. So when acceleration and velocity point in the same direction, the object is going to speed up and my acceleration is going to be positive. Now, if my acceleration and velocity point in opposite directions, so let's say this is my acceleration, it's going to be negative, and it's going to slow down my velocity. So I hope this video helped. If you have any questions, let me know, and as always, happy studying. If you found this video helpful, please take a second to hit the like button or comment down below. If anything in this video was unclear, or if you had a question about any other topic, please don't hesitate to comment it or send it to me in a message and I'll do my best to answer it for you. Thanks for your support, and happy studying.